Assalamu alaikum. Sequences part 2. Okay, in part 1, we identify the type of each sequence: linear, quadratic, cubic, and geometric, or we call it also exponential. In this part, we are going to find the nth term of cubic sequence and the nth term of geometric sequence, and also how to find the nth term of other sequences. Before I start, some students, they saw the first part and they asked about more examples about the quadratic sequence. If you remember, in part 1 we had two ways. I explained two ways to find the nth term. I believe they asked me to do more examples from the second method, which is using, if you remember, we were using 2a, 3a plus b, a plus b plus c. Okay, let's do one example. Let me add one more example. 4, 10, 18, 28, 40. That's the sequence that we have, and we need to get the nth term. Before I get the nth term, I have to identify what type of sequence is this. How we find out? We check the difference. First difference, if it's not the same, I check the second difference is not the same. I check the third difference. If it's not the same, I may check if we have repeated sequence. The sequence is repeating itself. So that's going to be a geometric sequence, or there is a common ratio. So from 4 to 10, that's plus. We need to add 6. To go from 10 to 18, you need to add 8. From 18 to 28, you need to add 10. And from 28 to 40, you need to add 12. So that's the first difference. First difference is not common. So first difference is not common, not the same, not constant. Okay, let's check the second difference. Second difference from 6 to 8 plus 2, from 8 to 12, from 8 to 10 plus 2, from 10 to 12 plus 2. So second difference, we are lucky. Second difference, second is common. If second difference is common, so what? That's going to be quadratic sequence. That's quadratic sequence, which means an squared plus bn plus c. As I told you, I don't have to have all of them. For sure, I must have an squared. But maybe I have an squared plus bn, or an squared plus c, or only an squared. Let's see. Right. I told you have two ways. I believe second way is easier, but the first way is also good because it gives you the sense. You should have this sense of writing the nth term of any sequence. Sometimes the sequence, if you go properly step by step, is gonna take time. It's too much working. But if you have this sense, sometimes you need just to have the sense. So I want you to balance between knowing the steps one after one and also to have a sense of how to find the sequence. Like, oh, this sequence looks n squared. For example, I may check quickly the first way. Like, I know now that this is going to be n squared. So sure it's going to be n squared. But what about a now? What's going to be a? A is the common difference divided by 2. A is common difference divide by 2. So that means it's going to be 2 divided by 2. So it's going to be 1. So it's going to be 1n squared. So n squared. 1n squared. And then you may find quickly what is n squared. N squared is 1, because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And then you need to compare. Maybe it's easy. Maybe it's obvious. Like, let me go back just to explain for you what I mean by it may be obvious. Like, go back here. For example, here, when I get 2n squared, I found that it's here 2, here -3, here 8, here 3, here 18, here 13. I found that every time I need just to subtract 5. I just need to subtract 5. This is how I got to n squared minus 5. Not every time is going to be easy, but you must get used to have this sense. Anyway, so if I'm using the first way, it's going to be here 4 and here 1. So here 4, here 1, here 10, here 4, here 18, here 9. My original sequence is 28, but here 16, here 40, here 25. And then how much is the difference? How much to go from 1 to 4? I need 3 more. But here I need 6. Here I need 9. Here I need 12. Here I need 15. Oh, it's not constant. It's not the same number every time. It's not 3, 3, 3, 3, 3. If it's 3, 3, 3, 3, 3, I would say n squared plus 3. If it's minus 5, minus 5, minus 5, minus 5, that's what I mean by it should be if it's constant, it would be n squared minus 5. Okay? But here is not constant, which means my sequence will be an squared plus bn, and maybe also plus c. Maybe. But for sure, we'll have bn. We have a linear sequence, because bn plus c, that's a linear sequence. Why is linear sequence? First difference is the same. Plus 3, plus 3, plus 3, plus 3. So I know now that it's not only n squared, it's not only constant. I have plus 3, plus 3, plus 3, plus 3. So it's going to be 3n. The linear sequence, the coefficient is the same. The coefficient is the same as the first difference. So it's going to be 3n. Is it only 3n or 3n plus some more or minus some more? How I check? Very easy, guys. Easy. I don't need to memorize too much equations. Put n equal 1. 3 times 1 is 3. But I need, and here is 3. 3 times 2 is 6. And here is 6. Yes. So it's only n squared plus 3n. And that's the sequence that is going to give me 4. It's going to give me 4, and 10, and 18, and 28, and 40. And you want to check it? Check. Put here 1, and here 1. It will be 1 squared plus 3 is going to be 4. Put here 2, and here 2. It will be 4 plus 6. 4 plus 6 is going to give me 10. Yes, it's a 10 here. If you put 3, it will be 9. Plus 9, it will be 18, which is correct. I'm sorry, I know that you were looking for the other one, but also you should know this as well, because this gives you like this sense of comparing the original sequence to the n squared sequence, and then you see how much is difference, how much more. That's good to know. But anyway, I'm sorry, I'll explain it quickly again. The video is gonna be long again, and some of you will be upset of this, but what can we do? You can, guys, you can move forward too. It's fine. So 40. Okay, so the other one, which I believe it's simple, shorter, you get the first difference, which here plus 6 plus 8 plus 10 and plus 12. Okay, and then you get plus 2 plus 2 plus 2. And you have to know this for quadratic sequence. For quadratic sequence, this is a rule. Quadratic, this is a rule. 2a, 2a, 2a is equal second common difference. Common difference. Okay, what is 2a? Here is 2a. So the 2a is equal to, and 3a plus b, 3a plus b is equal the first difference. First difference. What I mean by the first difference is not common. It's a 6 here and here 8 and here 10 and here. I need the first one. The first one of them. So which one? So I mean this. So 6 is going to be 3a plus b. And then a plus b plus c is going to be equal the first term. First, not first difference, first term. First term. What is the first term? 4. So the 4 here is going to be a plus b plus c. From where we start? From the bottom. We start from the bottom here. From 2a, so it's going to be 2a equal 2. Divide by 2, so a equal 1. We got a. Now let's go and get b. 3a plus b equals 6. So now I know how much is a. So 3 times 1 plus b equals 6. And then minus 3 minus 3. So b equals 3. We got b. Now let's go get c. A plus b plus c is going to be the first term, which is 4. We already know how much is a. A is 1. B is 3. C we don't know. Equal 4. 1 plus 3 is 4. 4 plus c equal 4. That means c is equal 0. Oh, that means there is no constant. So now let's go and write our sequence. Don't forget, our sequence is an squared plus bn plus c. A is 1. I can ignore it. So to be n squared. To be n squared. B is 3. So plus 3n. C is 0. So we can ignore it. That's how we do it. Okay. So let's go now back again quickly now to the cubic sequence. Cubic sequence. خلاص, I know that you know how to do it. Cubic sequence. You need to know the cubic sequence is an cubed plus bn squared plus cn plus d. But don't worry. 99% of the question, it just comes n squared plus d. Only it comes as n cubed. Sorry, I said n squared. I mean n cubed plus d. So the question comes like 3n cubed plus 5. Maybe just like that. n cubed minus 1. Just like that. 2n cubed minus 4. That's all the question that comes in the cubic, about the cubic sequence. Okay, so let's take one here. Okay, now let's find this first difference. I told you here's cubic sequence, but in the exam, in the extended exam, doesn't say. You need to figure out. So you now need to figure out from negative 6 to negative 4 is how much? Plus 2. And don't forget, you can use a calculator. From negative 4 to 10 is plus 14. From 10 to 42, it's 32 plus 32. From 42 to 98, you can subtract. 8 minus 2 is 6. 9 minus 4 is 5, so 56. And maybe we need one more. I think that's okay. 14 minus 8 is going to be 6. 8. 17 minus 9 is going to be 8. So 86. Okay. First difference not the same, and we already know, because we know already that it's going to be cubic sequence. So now plus. From 2 to 14 is plus 12. from 14 to 32. 14 to 32 is going to be 18 plus 18. From 32 to 56, 6 minus 2 is 4, 5 minus 3 is 2, 24, and 6 minus 6 is 0, 8 is going to be 30, and second difference is not the same, so not common, not common, not common, so we need to check the third one now. So as you see now, plus 6, plus 6, plus 6, and as you see, third difference is common. So it is cubic sequence. Okay, cubic sequence. Now, how we'll get A, B, C, D, teacher? We have also two ways. But I believe in this one, in the cubic sequence, only use the first way. Because too much, you guys, if you use the other way. It's too much equations. And most of the time, it's very simple. So no need, just to go now. Just you need to know one thing, is how to find A. How to find A. So I know that's going to be A n cubed. Okay, so how I find A? A equals common, the third common difference, divide by 6. So guys, okay, quick review now. For linear, A is the same. For linear, the coefficient of n is the same as a first common difference. For quadratic, A, the coefficient of n squared, is the second difference divided by 2. For cubic sequence, divide by 6. So it's the same for linear, divide by 2 for quadratic, and divide by 6 for cubic. So now I see it's 6 already, divide by 6. So to be 6 divided by 6 equal 1. Halas, we know A is 1. So we need to write it. You can write n cubed. N cubed. Let's find the sequence of n cubed. 1 cubed, 1. 2 cubed, 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. And then compare. Bring your original sequence here. Here. Put negative 6 here. Negative 6. Negative 4. 10. 42. 98. Okay? And then compare now. Just subtract. I'm telling you, just subtract. You want to know how much is the difference between them. To go from 1 to negative 6, how much? So that means negative 6 minus subtract. If someone is confused what we do when we compare, we just subtract. I want to know, n cubed is 1. How much to go to negative 6? That's negative 7. If you don't understand this, just subtract. Negative 6 minus 1. Negative 4 minus 8. Negative 4 minus 8 is negative 12. 10 minus 27 is negative 17. 42 minus 64. 42 minus 64. If you are using the calculator, is okay. If you don't use calculator, subtract normally. So how I mean by subtract normally? Subtract 64 minus 42. But you have to know that the sign is going to be negative. 4 minus 2 is 2. 4 minus 2 is 2. And 6 minus 4 is 2. But the answer is going to be negative. Okay? Did you get what to do if you're not using calculator? So negative 22. I think it's enough. Now we can see. As you see, guys, is it common? Actually, unfortunately, it's one of the hard ones. It's not common. But I'm lucky. It's minus 5. So I got linear sequence here. What's linear sequence? It's going to be bn plus c, or Here you call it, because it's quadratic, I mean it's cubic, so it's going to be only the Cn plus d. Maybe it's only Cn, and maybe Cn plus d. So easy now. I can see now it's a negative 5 every time, so it's going to be negative 5n. Oh, let's use the actual pen. So it's going to be negative 5 pen, negative 5n. And again, how to find the adjustment. If you put n equal 1, it will be negative 5. From negative 5 to negative 7, how much you need more? I need to subtract 2 more. Maybe check for 1 more. Put n equal 2. Negative 5 times 2, negative 10. Minus 2 is going to be negative 12. Okay, maybe you need to check 1 more. 3. Negative 5 times 3, negative 15. Minus 2 is going to be negative 17. So that could be one of the hardest sequence in cubic, which I don't see it's hard at all. So it's going to be n cubed minus 5n minus 2, and that's a cubic sequence. Okay, now let's go to geometric sequence. That's easy. Alhamdulillah, that's really easy. Geometric sequence, when we have a common ratio. Remember geometric sequence? Here we are. Look, 100, 50, 25, 12.5. Every time we multiply by a common ratio. So now let's take example. Maybe, for example, I can use the example at the top, by the way. I can use the same example at the top. 100, 50, 25, 12.5, and so on. So I can see now it's not common difference at all. It's just common ratio. You multiply by half, and never to say divide. Just say multiply. Okay. So what you need to know now about the geometric sequence, you need to know that an, if you want the nth term, is going to be a1 times r power n minus 1. Amazing. Easy. What is a1? First term. What is r? The common ratio. So first term and the common ratio. Okay, here what the first term? Is 100 times. You can use times by making a dot here. What is the common ratio? It's a half. Power n minus 1. That's it. Easy. I told you guys it's really easy. You need another one? Okay, I can hear someone says another one. Give us another one, teacher. Okay. What about 8? Okay. 16. 32. 64. Boom. Yes. Okay. Now, someone say, teacher, should I check the common differences or I check the ratio? I believe if you check the ratio, it doesn't take time. It's just like, boom. Just check the common ratio first. Don't waste your time checking first difference, second difference, third difference. No, check the ratio first. I can see times 2. Oh, great. Common ratio. So the nth term is going to be a1. First term is what? First term is 8 times the common ratio. The common ratio is what multiplied by every time? It's 2 power n minus 1. That's it. That's great. Alas, finish. But actually, I'm expecting that it will come in. This question never came before. But I'm expecting there will be a question like that. It's going to say prove or show that. Actually, they don't say prove. They say show that. Show what? He would tell me, show that the nth term here is going to be 2n plus 2. Oh, how 2n plus 2? And it's 8 times 2n minus 1. Now you need to go to the indices. You need to know that 2 is 8, 8 is 2 power 3 times 2 power n minus 1. And you know, if you multiply two powers with the same base, you add the power, so it will be 2, 3 plus n minus 1. And 3 minus 1 is going to be plus 2, so 2n plus 2. I believe that this question is going to come one time. It doesn't come before, but I believe it's going to come. That's the geometric sequence. Really, really easy. I don't see anything hard about it. Okay, last thing is other sequences. Sometimes you go fractions. When you give fractions, try to do, what you need to do is what? Do the numerators separately and the denominators separately. Do the numerator separately and the denominator separately. So that's what I'm going to do right now. Okay, so I can see all of them fraction except one. To make just sense, I'll make it 1 over 1. So all of it fraction now. Okay, so don't forget. So n, the first term is 1 over 1. The second term is 1 over 2. The third term is 1 over 3. The fourth term is 1 over 5. The fifth term is 1 over 5. Okay, I can see it's always 1 at the top. So the nth term also will have always 1 at the top. So it will be 1 at the top. Okay, what about the denominator? Look at the denominator as a separate sequence. From 1 to 2 to 3 to 4 to 5. There are two ways. Some students are smart, very smart. They will say, when n is 1, it was 1. When n is 2, it was 2. When n is 3, it was 3. When n was 4, when it was the fifth term, it was 5. They will say, oh, it's the same like n. So it's 1 over n. Someone would do this. Amazing. This is smart guy. Another one will say, teacher, it's a linear sequence. 1 after 1 is 2, so plus 1, plus 1, so plus 1, plus 1. So it will be 1n. So it's a linear sequence, it will be 1n. And 1 times 1 is going to be 1, so it's just be 1 over n. Let's do the second one now. Okay, the same idea. It's always 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So it's 1 at the top. Okay, someone would say, teacher, first term is going to be 2. Second term is 3. Third term is 4. Fifth term, fourth term is 5. Fifth term is 6. So what? So I can see every time is n plus 1. I can see it's n plus 1. Look, that's what I'm talking about is a sense. Is a sense. But if you want to use the proper way, okay, it's from 2 to 3, so I added 1. From 3 to 4, I added 1. From 4 to 5, I added 1. It's going to be 1n. 1n. As you know, guys, we don't need to write 1n. We can just write n. But is n enough? If n is 1, it's going to give me 2? No, I need 1 more. If n is 2, will I get 3? No, I need 1 more. So the adjustment here is 1. It's going to be n plus 1. Okay, last one. Actually, not last one. So, again, I can see it's always 1 at the top. That's not the case every time. Sometimes it's not 1, by the way. It's not 1. But anyway, it's 1 here. And I can see now when n is 1, it's going to be 2. When n is 2, is 4. The denominator is 4. When n is 3, the denominator is 6. As n is 4, the denominator is 8. I can see now that the denominator is always 2 times n. It's 2 times n. Okay, amazing. Look, that's what I'm saying when you observe, when you note something. But anyway, I can see now it's a plus 2, plus 2, plus 2. So it's going to be 2n. Do we need adjustment? Let's check. 2 times 1, 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. خلاص. So no need for adjustment. It's 1 over n. The last one, or let's take it as a homework. Let me know in the comments now if you can do the last one here. It's a good idea. Do the numerator separately, and do the denominator separately, and just make it as a fraction or a rational at the end. So see how much is going to be up here, maybe quadratic, maybe linear, maybe cubic, and see what we have down here: linear, quadratic, geometric sequence, and then you will have the NSEM. I'll give you this as a homework, so have a try. Thank you guys, hope you enjoyed.